Hello, and welcome to C++ Weekly. I'm your host, Jason Turner. I am available for on-site training, contracting, and code reviews. Now, in this episode, I am going to begin a series where I am going to show you how to learn modern C++. And now, the definition of what modern C++ is exactly is certainly open to debate, but let's say, for the sake of these videos, that it is what is considered to be the current best practices for programming in C++. The current best practices are going to change as the language evolves and as we learn more about how to write better code for modern computers. Now, the point of this particular video series is to give you the tools that you need to be able to be always writing modern C++ and learning on your own what the current best practices are. So I'm going to be starting in Windows for this particular example, and this is a very recent install of Windows 10. The only changes that I've made to it is to scale the user interface so that it is more visible when you are watching these videos later. And if you are a longtime viewer of the show, then you are probably wondering why I'm using Windows today instead of Linux, but I am going to be using Visual Studio for these examples, and specifically the Visual Studio 2017 Community Edition. Now I'm going to go ahead and download that now, and like I said, I haven't installed anything at all yet, so I'm just using the web browser that comes with Windows. This is the download that we want, is the first download here, the Visual Studio 2017 Community Edition, and that is free download from Microsoft. Community on C++ computer. Okay, we have finished. Video is we're going to from online, and we just tool down at Visual Studio and get another add-on from GitHub that's not in the marketplace. If we search here for the GitHub CPP Check Visual Studio extension, we can find this one from Violet Giraffe CPP Check Visual Studio add-in. Now there are a couple of different versions of this, but this one will likely do what we need it to do. And we can see here that we have our multiple installers going, and we needed to allow this Clang Power Tools and Clang Format once to finish installing. So we have installed the plugins for CPP Check, Clang Format, and Clang Power Tools. So we need a couple more things. Plugin, you can see that there is a link to it here from the clients and plugins list, and we've got CPP installed like we think they should be. So we can see that we have CPP Check installed here, Clang Format here, and hopefully we also have Clang Power Tools installed correctly. But that is not something that we'll be able to see until we create our first project. Be sure to subscribe, follow me on Twitter, and check out any of the links below. Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for on-site training, code reviews, and contracting. Now, in the last episode, I started a series on learning modern C++ by using the tools that are available. And I'm going to continue that now in this episode with setting up your first project and writing a simple Hello World program before. A Linux Power Tools cross-platform device unique warnings and capabilities while being able to call Clang Tidy and Clang++ and getting its unique warnings and abilities. And we can integrate CPP Check and the Clang Format tool. Now, it'll probably be a few episodes until I actually get to Clang Format, but we will discuss the other things leading up to that. Visual Studio is also one of the world's most widely used, if not the world's most widely used IDE, so there is no question that many people use it. And starting with the Community Edition Visual Studio, which we are using here, it is free, so pretty much anyone in the world can download the Visual Studio Community Edition and be able to follow along with some of these examples. So I think these are all good reasons to use Visual Studio for these examples. Getting the exact same capabilities on Linux is virtually impossible because of the lack of ability to call Microsoft's compiler, and using a different tool, such as Visual Studio Code, does not give us the same integration with Clang Tidy that I'm looking for. So that's basically where we are at the moment. There might have been some other options, but I think this was a good decision. So we're going to start by setting up our new project. And we wanted to use an empty C++ project. You can see here that I have it in my recent project templates, but if you don't have that in your list yet, you can just type empty and it will autocomplete for you, and you can choose empty C++ project. And we are going to name this one C++ Weekly. And again, empty project. This is going to have absolutely no files in it at all. At the moment, we're not going to be adding it to source control, although I would highly recommend that you use the GitHub integration and create your own private repository for actually keeping track of the stuff that you're doing. So we have no project here at all. We're going to go ahead and create our first source file, which is going to be a C++ file that we're just going to call main.cpp. This will be pretty much where we'll do all of the work for these examples. Although in a real-world project, you would want some sort of organization definition and structure. So we're going to create another file. Now, granted, Visual Studio doesn't have built-in support for the particular file that I want to create, but I think it'll cooperate with us here. We're going to tell it that we're creating a C++ file, but we're just going to name it .clang-tidy, and it should be okay with this. And sure enough, it is. And this is going to be the file that our clang-tidy is going to load its settings from. And we are using this file because this, again, kind of gets us working towards the mentality of cross-platform. We're not going to save the settings that we want for clang-tidy in the Visual Studio IDE. We're going to save it in our directory folder here, and then if we were to run clang-tidy from any other platform, it would still pick up the same things. So clang-tidy has many, many checks that it can perform. We are going to enable all of them. In a real-world project, you might not want to enable all of them, but all of the rules in clang-tidy exist for some well-thought-out reason that someone had. Some of them are security flaws that can find, others are just coding best practices, modernization, that kind of thing. We're just going to enable them all for right now because we're doing this as a learning experience. Now, we also want to make the Clang Power Tools easily accessible to us, and we're going to right-click here on our menu bar and enable the Clang Power Tools menu. So now we have these options. And we're going to go into our settings, and we're going to tell Clang Power Tools that, yes, we want it to fix errors that it finds. This will become interesting in a moment. And we want it to grab the list of checks from our .clang-tidy config file. So that should be all that we need to do here. Now, we're also going to set up our CPP check options. And we want to enable this inconclusive checks here, which gives us some very interesting results. So that checkbox is checked. And we have here -- enable equals all. I added that previously, and this says enable all of the possible checks that CPP check can do, including things that it's not sure about. Now, CPP check, I have never seen it give me a false positive, or maybe very, very rarely a false positive on one of its warnings. But in a couple of cases, it might contradict with the warnings that we get from our other tools, and these will be good learning experiences when our tools contradict each other. So we're going to leave that there. And now finally, we want to set our project settings in Visual Studio. Now, I have zoomed the UI, so we don't actually are able to actually see the OK button down here, which is a bit disconcerting. Even if I try to resize this, it doesn't quite work, but I think it will be fine. We want to specify warning level 4 to start with, and we want to double check that permissive minus is set, which means it's not going to let us do things that are outside of the C++ standard. This is great. We really want this as our default setting in Visual Studio, and I'm very happy to see that it seems to have been the default setting here. And finally, we want to set the language standard to C++ latest. Now, Visual Studio does not support all of C++ 17 yet, and it does not support really, just pieces of C++ 20 yet, but really that's okay because no one is supporting C++ 20 yet, and we're only into the first few standards meetings of what C++ 20 even means. So hopefully we have our settings all set. We'll hit enter to close that dialog to make sure it's set the settings. And there we go. We should be able to create our first Hello World example. So if you watched my video on using puts, you might be inclined to write your Hello World that looks something like this, as I would be inclined to do. This is just going to write Hello World to the screen and then exit. So we're going to save this file. So we're going to start by compiling with Visual Studio, and we're just going to hit build solution. And we don't really expect it to find anything here, and it does not. Now we're going to go ahead and run our clang-tidy checks. Now remember, clang-tidy is configured to automatically fix anything that it finds. So I'm going to hit this on our toolbar, tidy code. So it has applied one fix for us. It says here, clang inclusion of deprecated C++ header, stdio.h, consider using C stdio instead. So stdio.h is not actually part of the C++ standard. If you want to use these C functions like puts, then you need to use C stdio. And so it has automatically applied that fix for us. Now we are going to say, well, you know what, this is not really C++. Anyhow, let's go ahead and use our IO stream setter. And if you're following along with examples on the internet, you probably see code that looks like this. This is a fairly typical example. So if we compile and run this now, we are, again, not getting any warnings from Visual Studio, which is not terribly surprising because we're not really doing anything wrong. But if we run this with clang-tidy instead, we get this warning from the Google coding standards, which are sometimes maligned, but those that are implemented in clang-tidy are actually fairly helpful. This says, do not use namespace using directives, and this is true. Many people agree that using namespace is bad, even in a C++ file, because it imports all of those identifiers into the global namespace. So it is suggesting that if we wanted to instead, we could do something like using and pull that into the local namespace. And we can even see here that now we do not have a squiggly under cout, but we do under nline, and this starts to become, a bit difficult to manage. So a lot of people today would suggest that it is better to just explicitly name these things, depending on the context. There are contexts where you can't, but in these we can explicitly give the std namespace and do this. Now, this is not, with clang-tidy running, going to give us any warnings, I presume, and neither will CPP check. But if you are a fan of these videos, then you would probably notice the fact that I would not be using standard nline here. And let's go ahead and run CPP check just to be sure. And we did not get any errors from CPP check. So I would suggest to use our \n new line character here. So this is one of the cases where our tools will fail us, if you will. Now, granted, this is one of my best practice rules, not one of the widely accepted best practice rules, but the tools that we have are not going to be infallible, but they will get us very far along the way as we are practicing our C++ and trying to learn the current modern best practices. So this wraps up episode 2 of creating our initial Hello World for our Learning Modern C++ by using the tools that are available series. Be sure to subscribe, follow me on Twitter, and check out any of the links below. Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I am available for on-site training, code reviews, and contracting. Now, this is our part 3 in our series of learning about modern C++, and specifically we are doing that by using the tools available. I have Visual Studio set up with Clang Power Tools, CPP Check, and Clang Format extensions. I suggest that you go back and watch the previous 2 episodes for what the series is about and my reasoning behind using Visual Studio for these demonstrations. So in this episode, we're going to discuss some of the things that we can learn with our tools about inheritance and class hierarchies in C++, in C++11, and moving forward. So we have here our base class with a single pure virtual function, and we have our single data member, and then we have our function here called doThing with the same name, then this class struct that inherits from base. So let's go ahead and save this, and we're going to run this through cling tidy. And again, remember, we have all of the settings turned on for cling to automatically apply fixes where it can. So the first thing that we notice is that cling tidy tells us the constructor does not initialize the data field, and this is fairly important because we actually had code here that could have been operating on uninitialized data. This primitive type of an int is not initialized by default. So this very simple check right here could theoretically catch many bugs in your code if you happen to have uninitialized data that you're operating on. The next thing that we notice is our doThing function here actually is not overloading, it is hiding the base class member doThing. And it is very possible that this is actually a bug in our code where we have unintentionally hidden base class functions by changing the signature of them. And then we also see our parameter I is unused, and we get that it has commented out the name of I for us here, so that it still has a name, but it is now no longer a quote unreferenced formal parameter as you would have gotten in an error from Visual Studio's compiler. So let's go ahead and fix these things. We actually did intend to override, not hide the base class member, so let's just go ahead and remove this name altogether. And we like the fact that it is initializing using the uniform initialization syntax to the default value, which is going to be 0 in this case for an integer. And let's go ahead and rerun our cling tidy. So we can see here now that cling tidy has changed our method from being virtual to being override, and this is great. This actually protects us from ourselves, and I believe that is the only change it made, and that is correct. It used virtual, it used override here instead of virtual. Now, if we were to go back to this previous version where we have some integer in here, let's just call it int for now because we don't have a reason to name it. Now we get from Visual Studio immediately an error telling us that we have marked something override that is not actually overriding a base class member. So we know that we've done something wrong. This is the point of the override specifier, to let us know that we have done something incorrect when we intended to override, but we're not actually overriding a base class member. So this is the compiler and the tools protecting us from ourselves. Now, we haven't run this through CPP check in a while. Let's go ahead and run CPP check. And it does not yet have anything else to tell us. So we have our struct base and derived here, and now let's go ahead and put in some code that initializes one of these. After all, what is the point of having virtual functions if we're not going to be operating on these things through a base class pointer? So we've created our base class object, and we're calling our doThing member function on it, and we'll rerun this through cling tidy now. So cling tidy is able to tell us we have a potential memory leak here, which is great. It is true that we do in fact have a potential memory leak. So we're going to also run this through the Visual Studio compiler, and we get no warnings there. So to address our issue here, we're going to add a delete in, and hopefully this should have satisfied cling tidy. Now it is telling us that we are deleting an object called base that is abstract but has a non-virtual destructor, and that is true. So if we're going to do this correctly, then we need to add a virtual destructor to our base class, and we'll do it like this, and rerun our cling tidy again. So we have seen that cling tidy made a transformation for us here. We had code that looked like this, and it made this equals default instead. This is better because it more clearly tells us and the compiler that we're doing a default destruction. We're not trying to actually specify our own. But then we also get this warning that basically says we're not following the rule of 5 or rule of 0. So this warning tells us we don't have our copy constructor, copy assignment, move assignment. So let's go ahead and do those. So we have created all of our special member functions, and in the process created a new problem for ourselves that we no longer have a compiler created a default constructor. So we will go ahead and specify that also. So finally, we have it compiling again without any warnings. Now, this is the kind of thing that falls into the category of lots of little gotchas. We didn't know that we needed to create a virtual base class destructor, but the compiler told us that. And once we did it, we didn't realize that we had actually implicitly disabled our move operations, but the compiler told us that as well, or cling tidy told us that as well. So we were able then to apply those, and in the process, we accidentally disabled our defaulted base class constructor, and so we just had to explicitly default it, and now this works. We have cleaned up all these problems. And this this is good. This is what we want. So we don't have to necessarily be afraid of accidentally leaving something out when we are using the tools that can show us what exactly it is that we could have done better. Now, the problem, since I am going to point out along the way where the tools have failed us, is that really in this example, there's no reason to do dynamic memory allocation at all. And indeed, if we were going to, we should not have had a new here. We should have been using a unique pointer. So let's go ahead and make this a unique pointer. And we will include our memory header to do that. And then here we will say, and we no longer need delete. And the Visual Studio using a unique pointer and to do dynamic memory better. Now, the problem, since I am going to point out along the way where the tools have failed us, is that really in this example, there's no reason to do dynamic memory allocation at all. And indeed, if we were going to, we should not have had a new here. We should have been using a unique pointer. So let's go ahead and make this a unique pointer. And we will include our memory header to do that. And then here we will say, and we no longer need delete. And the Visual Studio IDE tells us right away here that delete is meaningless. We'll delete that because unique pointer is doing automatic memory management for us. And let's see what Clang Tidy has to tell us now. So we have gone ahead and made our unique pointer here, and our tools are done giving us advice. But really at this point also, a human reading this code should have realized that we probably do not need to be doing any dynamic allocation at all, and should be doing something like this. But that is something that the tools are not really able to analyze yet and tell us that we are doing a dynamic allocation for no reason. That is good. So there you have it. This wraps up, for the most part, what our tools can currently tell us about inheritance and how to learn our, again, modern C++ practices. And remember, the tools are always being updated, and they will always be adding new checks that help us learn these things along the way. Be sure to subscribe, follow me on Twitter, and check out any of the links below. Hello, and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for on-site training, code reviews, and contracting. Now, this is the 4th episode in our series on learning modern C++ by using the tools that are available to you effectively, and we are in Visual Studio. I suggest that you go back and listen to episodes 1 and 2 for how we got the setup for this and why we are using Visual Studio. And in this episode, I'm just going to pick up where we last left off, and I'm going to talk about const and const expr a little bit, and we're going to see what other tools can tell us about that. Now, in the last episode, we had our derived and base, and this is all ended up becoming rather complicated to do everything correctly. And that was by following the rules that our Clang Tidy was giving back to us, which was great. It helped us get all the gotchas. But we also have this unique pointer here, and if you are an astute observer, you may have noticed that I did not use make unique. That is partially on purpose. Part of the problem is that I was creating a derived and returning a base object, which is one reason why Clang Tidy didn't catch it for us. But the other thing is that I'm really was just trying to steer you away from using heap allocations, because this is not something that we like to do. If we keep things on the stack, the compiler can optimize it better, and that's better. So we have this thing, and we realize it's pretty much over-engineered. So let's just go ahead and flatten this all out. We don't have any need for this. We have our data member, and we have our do thing, and we'll put the do thing here, and we'll get rid of this. And you can see all along the way that the compiler is telling us what we have done wrong very quickly. IntelliSense is here from Visual Studio. We have something that's override that doesn't override, so we'll get rid of that. And then we have this thing that is called derived that doesn't exist anymore, so now we have type. And let's just go ahead and give this a slightly more meaningful name. So we've got our object, and we're calling our function on it. Now let's go ahead and run this through Clang Tidy and CVP check and see what we get. I'm going to go ahead and remove that line. And this is some of the areas where CVP check really shines compared to other functions. It has this do thing can be made a static function, and this is a very interesting comment. It says making a function static can bring a performance benefit since there's no this instance. So it is entirely correct. Since this is not operating on any member data, we can just make this static, and it's still going to compile exactly the same, and the compiler may be able to do more efficient things with it because it knows that it doesn't need to care about the this pointer. But let's say that this is maybe not fair. What we really wanted to do for this do thing is return our current data value plus 4, something like this, just to make use of our local data. And so we're not modifying anything, we're just doing this. And we will rerun this now with CVP check. And now CVP check is telling us making this function const is what we want to do. And that's right, that's good. We should make all of our member functions const when possible. And so this is great. It's teaching us to use const where we should, and to use static when possible. So let's add our do other thing. And just for the sake of testing here, let's see if Clang Tidy gives us any other information. So there's no warnings from Clang Tidy, but one thing that we can learn here that our tools are not yet able to teach us is that this really could be const expr. And there's no reason to not make this function const expr. All of our data types in our structure currently are trivial, and this can work. So we have just done that, and maybe this is one of those things where the tools cannot yet teach us what we need to be doing to write our code as good as possible. So we've got our object type, and we've made our members const expr and const, and now let's call them. And we're going to do that with argc. So we say if argc is greater than 1, we call do thing, and otherwise we call do other thing. So we'll go ahead and run this through CVP check again and see if it teaches us anything else. So let's see what CVP check tells us. And we have here that CVP check says it has found the same code in if and the related else block. This is suspicious, might be a cut and paste or logic error. And wow, that's great. It really was. We really meant to call do other thing. So CVP check caught that for us. Now, we realize actually what we didn't mean to do here for this code was to call it in the case that argc was greater than 1. Let's go ahead and satisfy our tools like this. What we meant to say is if the size of long is greater than 4. So in this case, we're saying effectively, is long a 64-bit or a 32-bit in this code? Let's see what our tools can give us for this. So for this one, we are going to go ahead and build our solution with Visual Studio. And now we have this warning that was recently added in Visual Studio that says conditional expression is constant. Consider using if const_expr statement instead. So out of curiosity, let's see if our other tools can catch this. So this warning here is the one that is still from Visual Studio. We can tell because it says C4127, that's its code. And this one is the one that is coming from Clang Tidy. And it just says consider replacing long with int32. So that's, well, if we replaced long with int32, then we know that it would never be greater than 4. And we're trying to test something out here. So if we make this if const_expr, then we can satisfy Visual Studio, and it's the only tool that I'm aware of right now that will tell us when things could be a constant expression in an if const_expr kind of way. And this is helpful because it is actually guaranteed to only compile the given block of code if the constant expression is true, instead of if it's a regular if, then it's something that is almost certainly compiled away, but not 100% guaranteed to be. So that wraps up our episode for now, as far as what our tools can teach us about our const members and using if const_expr and const_expr members. Be sure to subscribe, follow me on Twitter, and check out any of the links. Hello, and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for contracting, on-site training, and code reviews. Now, welcome to the 5th episode in my series on using the tools available to learn modern C++. This will probably be the last episode in this series, and I want to wrap up by just covering some of the more interesting things that it is possible for the compiler to do for us with Clang Tidy specifically is what I'm going to be focusing on today, and just in general try to convince you, finally, if you haven't been already convinced, that using your tools to help you learn the evolving language is a good thing to do. So I'm going to give a couple of examples of some loops and some code and maybe some pointer passing, something like this, and just show you all the transformations that we can get across in one example of code here. Now, if you're used to programming in C++ previously, you probably have written many loops like this, or worse, perhaps loops that you have written that use the std : vector : iterator syntax, and you end up with quite the mess of loops that are kind of complicated. And fortunately, we have this feature now in Clang Modernize, it's been there for a long time actually, where we can run a modernization such as this. And it is entirely possible for the compiler tools with Clang Tidy to automatically convert this into a ranged for loop to something like this. And this can be applied with great success to a large code base. I've seen this kind of thing been able to be applied and have very few problems with the actual application. And similar to this, if you have perhaps been using C++ and C for a long time, you've probably seen code that looks like this. For example, null or setting 0 to a pointer value. And Clang Modernize is able to do something with this also. In C++ 11, we have null pointer, which is much more specific to saying that we're actually working with a pointer instead of a 0 value. Null is typically defined as being 0. Even for all the things that it can do, none of the tools that we have available can recognize that really here, for a system like this, we should have just used an algorithm. And really, this is the kind of thing that we should have gone with, is just using standard accumulate over the range begin to end of the vector and summing all the values together. Now, one thing worth pointing out here is, and this is why we really want to take the most advantage of all the tools that we have available, is we are summing a range of integers into an integer. But if we had instead had a range of floats and we're summing it into this integer right here, this actually sets the return type from standard accumulate. If we build with Visual Studio in this case, we can see here that we've got a conversion from float to int and possible loss of data. So this is something where Visual Studio can warn us in a better way than any of the other tools and compilers that we have available. So be sure, as you are learning the modern C++ techniques, to use all the tools that you have at your disposal. Visual Studio does give us a great way to integrate all these tools in one place, but Clang Tidy is available on every platform, and CBP check is available on every platform. Make sure that you familiarize yourself with the list of algorithms. They are, in fact, growing with every release of C++, and be sure to use these algorithms where you can to make your code cleaner and more expressive. And as I mentioned kind of in passing in the last episode, try to avoid using heap variables and try to stick with your stuff on the stack and keeping everything simple. Don't go for the over-engineered version that has a lot of inheritance all over the place. And that is unfortunately something that we don't get a ton of feedback from our tools. They don't have a way of doing a complete program analysis and saying, hey, by the way, you're using inheritance here with virtual functions when there was really no need to. So thank you for following along on this 5-part series in getting up to speed with modern C++. I hope you find the tools and these videos useful.